Morning and welcome. Thank you very much for joining this IMARC panel discussion on what is definitely one of the hot topics around, the role of machine learning and artificial intelligence in exploration and how this technology is reshaping the sector. None of us can argue the increasing role of machine learning and AI in many aspects of our businesses and private lives. My name's Alex Blood. I'm Executive Director Mining at the Department for Energy and Mining. This is a hot topic for us. We've just finished the ExplorerSA Gawler Challenge, which was a global data-driven machine learning AI competition ourselves, with over 90 countries participating and about to head into phase 2 to implement and test the models and also to pursue new data sets to inform machine learning and artificial intelligence geoscience. This panel is very, very important. I'm pleased to get straight to it. We want to spend all of our time with our panel members while we have them, because we've got an amazing collection of explorers, geos, and data science leaders. The full bios for this panel are available on IMARC's website. And so to introduce, firstly, Robbie Rowe. Robbie's Chief Operating Officer, at SensOre. SensOre is a company who aim to be a top performing minerals targeting company through the deployment of AI and machine learning techniques. We have Jack Maughan. Jack is a geologist and part of a new breed of data science geologist. He's currently working for BHP, and he was also winner of the ExplorerSA, the Gawler Challenge Rock Licker Prize. We have Andrew Fitzpatrick. He's Chief Geophysicist at respected explorer IGO. And last but definitely not least, Professor Javen, who is the Director in Advanced Reasoning and Learning at the world-renowned Australian Institute for Machine Learning. Our goal of this panel is to leave you with a better appreciation of the role of machine learning and AI and how it relates to exploration. So I just want to get straight to it, panel. And to set the scene for all our viewers, just a quick one to you, Javen, on what is machine learning and artificial intelligence in layman terms?
Sure. So machine learning is like the brain of the AI, where the AI have many other components, right? So, and there's a lot of misconception about a lot of the buzz terms like deep learning, computer vision, big data, and machine learning. So what are they, right? So AI, if you can see, allow AI to see, the eyes of AI is computer vision, right? But the brain part, how does the computer figure out what to do, how to do it, is machine learning. So before the time of machine learning, that if you want a computer to tell what is a dog, what is a cat, you need to come up with maybe 1,000 rules about how to tell if it's cat or dog. But with machine learning, all you need to show are just examples of the pictures of dog and cat. Algorithms can figure it out. So that's machine learning, right? So, so if you heard a lot about AI being applied, most of the cases in the industry is machine learning has been applied to help. So,
thanks, Javen. And so this brings the panel all in on our first big question together. What is your take on the state of play of AI and machine learning and how it's reshaping mineral exploration now? And what are the sorts of challenges we're faced in the exploration sector that this can help address? Maybe if I just start with you, Robbie, first cab off the rank.
Yeah, thanks, Alex. I think machine learning can assist in meeting some of the challenges in exploration, improving exploration performance, probably in two ways. The first way is it plays a leading role in transforming geoscience and consequently economic geology. The knowledge of those by quantifying the qualitative knowledge that we already have. And that qualitative knowledge has been developed over the last 100 years. And in the second way, it transforms targeting from simple detection, which is how we generally explore, have been exploring in modern exploration or conventional exploration, and introducing prediction and quantifying in a probabilistic way.
Thanks, Robbie. Andrew?
Yeah, I think everyone's excited about the opportunities machine learning is going to offer in creating new ways of analysing and exploring data. However, I am a little apprehensive that people may see it as the panacea to the exploration in its entirety, whereas I think the real wins will be applying it to the right question or problem. Current exploration challenges involve collecting a lot more data than we used to, so, multi-element geochemistry, core scanning systems like TerraCore and CoreScan, Mineralize, etc. These generate lots of data, so I think the big wins will be using machine learning to produce simpler end products for the geologist, like lithology and alteration indices. I think the other big value in machine learning would be providing an unbiased second opinion in analysing data and quantifying confidence levels, i.e. if it's predicting lithology in areas of low confidence, it's probably where a geologist is going to reassess the data in a lot more detail and get more value out of it, whether it's analysing core, geological or geophysical models.
Yeah, okay. Jack?
Yeah, absolutely. I agree with what Andrew just said then about we collecting a lot more data, and I think the way we sort of look at it through machine learning is we can start looking at relationships across all data sets rather than traditionally sort of focusing on one or two at a time. We got that real multivariate analysis that we can sort of do through machine learning at a whole new level.
So just picking up on the question, you've all raised data. So if data is what underpins the application of machine learning and AI approaches, what are your thoughts on data and knowledge? Do we have the right data and the knowledge that we need? Javen?
Oh, I didn't realize that data is for me, but it depends on the data you have in your organization. So quite often is that we try to start with some small well-defined problem, so that for which you're more likely to have the data you need. And then you can expand from that point on. So, and also it has been misunderstanding that machine learning always needs big data. So your data doesn't need to be big actually. With the modern machine learning, if you just don't get hooked up by the old ones, then there are a lot of methods that nowadays can give you very good performance, even with really tiny amount of data. So if you don't have big data, then your data may be sufficient enough for the modern technology. Also, you may have heard of a lot of things about deep learning. Deep learning is a subset of machine learning. It's one type of method of machine learning. And machine learning is very different from traditional statistics, right? So you may have heard of a lot of data scientists or statistics, they say, forget about machine learning, you just do stats. That's very different. Machine learning utilizes stats. Machine learning also utilizes optimization and many other stuff. But stats, they do not replace machine learning. They are very, very different. So what mostly you will find working nowadays is machine learning, okay? But again, stats can be very useful. However, they're just not the same as machine learning.
Thanks, Javen. And what about from the geologist perspective?
I can get that one. So from an economic geology perspective, I think the data falls into two camps. The first one is geoscience data, geophysics, geology, geochemistry, which is the data that you use has to be clean and it has to be appropriate for what you're trying to look at or predict. The second one, and it's often ignored, is quantitative understanding or quantitative knowledge about mineral deposits. We're really good qualitatively. We've been forensically studying mineral deposits for years, right? And there's lots of papers, but there's very little quantitative analysis of that information, especially when you go from the ore out and away from the deposit. So, a really valuable data set are really good candidate data sets, in other words, mineral deposit databases, and knowing the space, the tenor, the frequency of the data, the spacing of the data away from the deposit. That's really important and often ignored.
Thanks, Robbie. Andrew, you're doing this in the field on a day-to-day sort of decision-making base. What's your view on this?
Well, I guess data, it all depends on scale. So we're pretty lucky in Australia. We've got pretty competitive data across the landscape, and at continental and belt scales, that data is quite dense. Work by Matt Cracknell at University of Tasmania has replicated the 1 to 1 million geological maps using self-organized maps on these data sets extremely effectively. But my question is, when you get to the prospect scale, we've got to probably start putting these data in a 3D context, and maybe we should be doing machine learning on geophysical and geological models in 3D rather than raw data. And I guess from a knowledge point of view, machine learning may show us new associations that we didn't know about, but as a scientist, I'm really want to understanding the cause and effect is critical. So it might just drive us into a new area of learning that we didn't know about, which will be really great, and hopefully to find new processes and help us with exploration success.
Thanks, Andrew. Now, Jack, you've come from a geology background, but a big passion for data science. What are your thoughts on this?
I think one of the things I found out very early on in my journey is that our geoscience data is quite chaotic and varies quite a bit from company to company. So I think there's been quite a focus recently on trying to understand what our data actually represents from a systems point of view. What are we actually trying to get out of data by when we choose a survey or something like that? What are we actually trying to model? So yeah, I think it's there's still more to learn about what our data actually represents.
Can I just pick up, Robbie, briefly? You mentioned the issue of data cleaning, and it's really easy to skip over that, but it's fundamental to some of the approaches in terms of quality. Have you got any observation on thoughts on where we are in terms of data cleaning and the data preparation even before you've got to the application of machine learning techniques?
Yeah, that's a really good point. So a lot of data is available, a lot of historical legacy data is available, and then getting it and processing it, cleaning it ready for algorithms is absolutely critical. And my experience or our experience has been that it's a significant time and therefore cost to the whole process. You don't have to take my word for it. You can go and look it up, and just about anybody that works in the space, the range is between 60 and 80% of the time, and therefore cost investment is getting the data, cleaning the data, and getting it ready. So if you're playing in this space and you want to use it, then you have to invest a lot up front, and most of that's front end loaded. You've got to do the work before you do anything, right? And so a lot of time and cost investment up front.
So Andrew, as an explorer, an active explorer, how is IGO tackling the data cleaning sort of question?
Obviously, yeah, we have expertise in-house in the various fields, whether it's geophysics or geochemistry, to basically clean our data sets. And I guess from the machine learning perspective, we've had a few companies come to us now and run some machine learning algorithms. And from a data scientist point of view, they go, give us the raw data unfiltered. And I think they're sort of missing a part of the process, that as part of our data cleaning, we're actually enhancing data and improving signal and reducing noise. And similarly, the nature of the data is different. Like geophysical potential fields is a smooth, varying sort of field compared to other things like a dual core that might be disparate data. So I think the true power comes in integrating the sort of geological and geophysical expertise with the machine learning to also assist speeding up the process. And because some of these machine learning people are just sort of reinventing the wheel and maybe actually not honouring the data based on the physics and chemistry sort of properties we're looking at.
That's really interesting. So the Geological Survey of South Australia, as we move into phase 2 of Explorer SA, it's thrown up so many questions for us on the cleanliness, the data cleaning and the preparation of our own data sets. And we've got so much, but is it of the right quality that it's really able to support people in with these new techniques so that they can focus in on the problems they're trying to solve? Jack, you've worked a lot, and I know you're working with BHP in this space now. Have you got any sort of thoughts you'd like to share?
I think the sort of trash in, trash out, I think sort of done the rounds now within the industry, and people that sort of, coming to understand that the data has to be in a good quality state, otherwise it's not usable. But for a process, it's going to come down to, you're going to need sort of geological input as you start that sort of cleaning process, so you're not, I guess, undermining geological processes that are happening in the data that quite often a data scientist might ignore or just completely remove from the data set.
Okay, I think that's a good caution for anyone listening, the accident of removing something because you don't understand the context. So just picking up then, I guess, on that point, that's talking about the role of geoscientists with the data scientists. Do you think, and this is a whole panel question, that machine learning and AI is evolving and changing the workflows for exploration, or indeed the makeup of an exploration team itself?
I'll start off. I guess in the geophysics space, what I have seen recently that's really encouraging is some of our geophysical inversions, particularly in the electrical and EM space, are very computationally intensive, especially modelling in 3D. And these things can take weeks or months to calculate. There's been recent research using machine learning to basically fast track producing data models from data using machine learning techniques rather than full-blown inversion. And so you get a product, almost semi-instantaneously. So that allows you to QA and QC data in semi-real time. You may increase resolution of a survey over a particular area of interest. And then you can even use these sort of proxy models as starting models for our proper inversions and dramatically speed up the entire process. So that really is ground changing in my perspective. Sort of sitting outside the geology space, like NVIDIA, the graphics computer company, they're doing amazing noise reduction techniques. But basically, I could sit here in this seminar right now and basically be typing away on my keyboard, making a lot of noise, and they've got algorithms that will remove that noise background perfectly, again, in real time and enhancing the quality of the audio. So these are all things that we'll be able to apply, in the geological domain once we've worked out, where we can apply it appropriately. So yeah, it's really exciting niche stuff that we've never had the opportunities to be able to do before.
Any of the other panel members?
I think machine learning experts do need to work with domain experts, and quite often it's an iterative process. And also, just to follow on Andrew's earlier comment on causality or something that your model can be explained as well, which is also the difference between machine learning and stats. So in stats, what you capture is a correlation. So things they happen at the same time, or 7 days earlier, another event would happen. That's a correlation. Where causality is actually beyond the realm of stats. So causality will tell you what the causes were. So if you want to intervene or change something, what would happen? And that's something that's actually not in the kingdom of stats. And machine learning can do that. So through causality and other methods. So, and also now modern machine learning methods, they can be interpretable. So you know the prediction, why you give it that prediction. So you can use machine learning models as an artificial advisor, right, to give you other opinions. But the benefit is that they can give you advice much quicker. And also you can make, if you train 1,000 models, you can have 1,000 advisors, whereas it's very expensive to pay 1,000 advisors as humans and get them to work for you. So, but I do believe they need to work as a team and collectively. And also another message is that what we've learned is because we worked with diverse industries, including mining, but many other industries, is that some of the wisdoms or lessons learned in other industries that we're not aware of in the mining industry, but can be hugely beneficial if the mining industry is willing to open up and to say, let's adopt the success from a different industry. So that's also the benefit for working with machine learning teams, which often work with diverse industries. So I understand what Andrew's earlier comment about some machine learning companies. The problem with some of the machine learning companies, not all of them, some of them are very good. Some of them are maybe startups or with limited expertise only in one field. That could be a problem. So if they only tried off-the-shelf algorithm for your data, then you may cause problems. But if you work with really good teams which can innovate and invent new methods, bespoke product for you and for your data, and work with you, with domain expert, then that'll be ideal environment.
Thanks, Javen. That issue of transference and knowledge transference between industries is very, very astute. Have you got any views on that, Robbie, particularly with SensOres, I guess, focusing in on this sector now?
In terms of
the relation, I guess, in the workflow and the connection of the geoscientist specialist with the data scientist for that learning.
Yeah, I think all of the panel members have mentioned it already, that you need domain experts with working with data scientists. I think, unfortunately, for a while, most of the companies that have been trying to progress this data science with geoscience advisors, rather than the other way around, where they're geologists or geoscientists that are trying to predict or trying to answer questions that are geological in nature and getting assistance from data scientists. So I think the companies that will be most successful are the geoscience companies that are assisted by data science. Yeah, and I think, and going on from that, I really still, in terms of the workflow, I think we need to front-end load the investment in data, and we need to stop pattern drilling or flying geophysical surveys for whole greenstone belts or whole terrains, and we need to invest more upfront. Thanks,
Robbie. Andrew, have you got any thought on again, IGOs, I guess, in the ground with their drilling and other programs? Have you noticed that need to change the way you're looking at your programs and designing your programs?
Yeah, I was just going to change tack and not talk about the exploration process. I mean, it's part of exploration, but sort of the business development opportunities that companies like us face on a day-to-day basis, where we're looking at other companies and potentially joint venturing with them or so forth. And we get access to these, data rooms that, obviously have years and years of data in it. And, our job is to can you look at this, and you've got a week or maybe a month to assess, the value of that data. And I think there's a huge opportunity for machine learning, basically to grab that data, analyze it, pull out the outliers, the anomalies, and things that, would help us make a business decision on whether we enter that joint venture or not. Again, providing just a second opinion in our analysis, because, basically to try and sort through, years and years worth of exploration data in the matter of a week or 2 weeks is obviously quite a difficult task. And so you always take the first pass over look at it. But if we can run machine learning algorithms to extract more information and value out of that data in a quicker time frame, that'd be a great win for industry.
That'd be a real evolution of how data rooms get explored and actually leveraged off too, like big change rather than trawling through reports. Jack, any thoughts?
I think that's pretty well the way it's going. One of the things that I'm sort of excited for is how we sort of complement machine learning with existing geostatistical techniques and that kind of thing, and not sort of replacing processes like co-kriging and that kind of thing, but really, implementing some of these machine learning algorithms with existing techniques and getting the most out of what we've already got established.
Have you noticed any barriers to that I guess because you are a geoscientist who is embracing data science and sort of coming at it at the start of your career, in the earlier phases, are you seeing any barriers or any challenges?
I think it's mainly just the translating between hardcore data scientists and hardcore geologists, trying to get that connection across.
And what do you think is the biggest challenge in that you've come across?
It's just spending time together, getting everyone together and actually understanding what everyone's talking about.
And so this next question is actually just for you, Jack, because you did win the Rock Clicker Prize, and it is the best named prize in that competition.
A nickname I'm not going to shake anytime soon.
What are the opportunities that you see to reshape mineral and petroleum discovery? Because I know you're also linking into the application of this in petroleum and the sort of changes you're noticing in your work there.
It might sound a bit backwards, and I don't know if this is just because I'm still sort of early in my career, but I'm finding I'm doing a lot more geoscience through machine learning. I'm spending a lot more time reading back through papers and trying to understand geological processes, because I'm seeing that when I've interrogated the data more. I've sort of taken that extra step, not so much following the methodical exploration techniques, but really starting to interrogate the data and looking at all these multivariate things, seeing things that don't make sense, and quite often it's just purely due to the data, but seeing things that I probably would have never questioned before and thinking, why is the data doing that? What is it representing? So I'm really starting to bring in a bit more science into the geology, which is odd considering the sort of stigma around machine learning as it's taking our jobs.
Can I then just pick up on that and throw this question to the panel, picking up on Jack's last comment about, then there's clearly a question of capability, capacity and skills. What do you see as the opportunities in there for the sector, but also the things that we need to focus on to make more geoscientists understand the opportunity, more data scientists understand the geoscience debate?
Well, there's a couple of approaches here, I guess. There's obviously cultural changes, and Jack pointed out, there might be barriers between being a pure data scientist and a geologist. And probably go back a couple of decades, there's probably no difference between a geophysicist being on an exploration team. So these things, you build relationships and, you understand each other's problems and what everyone can add to the table. I know a lot of companies are now starting to employ data scientists, and some people don't see this as they're going to run their own algorithms or machine learning in-house, but it's going to produce that sort of conjugate or boundary spanner between the actual company and external consultants, research organizations, or universities doing the machine learning. So really just pretty well embracing it. It's a new thing, and some people get scared of the new and other people embrace it. And I guess, if you're at the forefront, then you embrace it and try and use it and put it into your business process and maximize value out of it. But one analogy I was thinking about the other day was basically, it's like building a house. So let's just say the data is the timber, the concrete, the bricks and the roofing. It's all sitting outside. You're not going to rely on machine learning to build that house. You're still going to have to rely on the tradespeople to build it, the experts in that piece. But you might use machine learning to optimize how to build that house, make it more energy efficient, make it more strong, make it better. So again, it's just a part of the overall structure, and that's how this is going to help exploration in the future as well. It's just a part of the big piece.
And part of the optimization. That's a really good analogy. Robbie, have you got any thoughts?
Yeah, I'll probably go a little bit further than that. I actually think it will disrupt mineral exploration going forwards. It's disrupted every other sector. And so I think we're about to be disrupted. And as a consequence, I think the geologists of tomorrow working with machine learning are going to have a lot more exciting job. They're going to go from going out and collecting qualitative data, either on drill rigs or on drill core farms or whatever, and they're going to be working with the data more. As the data becomes more quantitative in nature, they're going to have a lot more exciting job. Are there going to be less geologists? I don't know. Maybe there will be, but the geologists of the future are going to have a much more exciting job than just collecting data. 90% collecting, 10% thinking. I think in the future, much younger geologists are going to be thinking a lot more about geoscience, which I think is just so exciting. Consequence of this is that geologists as a whole, I'm not talking about geophysicists or geochemists, but geologists, they're going to need to be a lot more numerate than they currently are. And that's a question that all goes back to education and the requirements. So again, I think it's really exciting time to be a geologist and an exploration geologist into the future.
It does sound like this is an education evolution as much as it is.
It is.
Evolving the exploration sector. Javen, do you have any thoughts? Because I know it.
Yeah. So there is a shortage of machine learners. We couldn't keep up training enough machine learners to help all industries. So that's a fact. And we have to figure out how to speed that up, and also with quality guarantees. And also, I like the analogy from Andrew for the building a house. You can use machine learning to help to assist the design and or help some part of the house building. But also, you can build a house in a completely new way using machine learning and robotics, which is the reality actually. So some of the companies, they are building houses completely with robots. So, right. And also I know that you also use analogy, but also in other cases that we worked with domain experts in mining and other industries too, but in mining, our domain experts initially, they really resist. They want machine learning only to work on the workflow they had to improve some step of their workflow. And after a few months, they realized now after we present result and not using their workflow, we use it as well, but we also do in both, right? And without using their workflow, just bypass a few steps that they had, producing fantastic outcome. And then finally they agree, yes, you're right. It works, but I would never believe it before I saw it. So you can actually build house just with robots, just with machine learning. But there's a journey to build the mutual trust. And of course, you shouldn't trust anyone without seeing the hard evidence. So
we like that. We like evidence. Thanks, Javen. I'm going to wind up because we are coming to a close. This has gone way too fast. But Jack, I hate to put you in the spotlight, but as I think representative of the next generation of geoscientists, because of your focus, I think you can have the opportunity of closing us out. Robbie made a really good point about we're not replacing boots on ground, but we will be evolving. Andrew's raised some really good observations. Javen's commented on not enough students coming through machine learning. You're this amazing mix of both. What are your thoughts on what we need to do moving forward to be absolutely ready for this for the next generation of employees coming up?
Yeah, good one.
You can kill me later.
Learn to code. No, I think, yeah, just get an understanding of what it is now. I think there's nothing I'm aware of at the university level that sort of marries the two, the geoscience and the data science. So it's really going to come down to young geos that are keen to get into the space, but it's moving quick. And I think that sort of boots on the ground type geology with exploration is moving further and further undercover. So we're going to need new techniques.
Thanks, Jack. And it does raise an interesting question for all of us to pursue at the university and the education level. So thank you very much for joining this amazing panel this morning. I hope you really enjoyed it. I think you've realised that machine learning and AI has a role in mineral discovery. It has a role in exploration, but we can certainly see there's more to this than just a data scientist. It's a marriage of skills. It's an evolution of how we consider the problems that we have. And right back at brass tack basics, it's about good data and how we manage the data. So thank you very, very much to the panel. I hope to see you all again soon, and good morning.
Thanks very much.
Thank you.
Yes.